Hey guys, so in this video I'm going to be talking about the TA-Lib library, which is a library written in C++ that allows you to calculate very fast many technical indicators, and it has wrappers to many languages, including Python, of course. So TA-Lib library, as you see, talib.org, has many things. Look at all these indicators it has. It has, of course, wrappers in Python and TA-Lib, stuff like that. Even Pandas TA uses this. But I like using the TA-Lib without Pandas TA. It works better for me. So anyways, we'll talk about this library. First, I'm going to talk about the installation, because the installation is a pain in the ass if you try to do it without Anaconda. Because without Anaconda, it requires you to install TA-Lib separately, which even with Linux is a pain in the ass, but with Windows is even a bigger one. But with Anaconda, what you could do is you could create a Conda environment with Python 3.10, because it doesn't work on 3.11, and you can easily install it with one command. I'll show you guys how to do that. I'll show you guys the basic usage of how to calculate the indicators for a specific symbol. I'm going to show you how to compute them for all the symbols at once. I'm going to then show you how to plot these indicators, and then we'll create a cute dashboard with Ipywidgets. So an example of this cute dashboard would be something like this, where you select the symbol. So let's say I select Tesla, I get the Bollinger Bands, I get the RSI, I get the MACD, and let's say I do another symbol. Let's do I don't know. Let's do Google. So I do Google, I get the Bollinger Bands, RSI, MACD. So I thought that would be cool. So let's get started. So first, the installation. So you really should use Anaconda, otherwise it's a nightmare. And if you guys are interested, please leave a comment, and I can make videos with more in depth on how to set up Anaconda environments, how to create Anaconda environments in IPython notebooks, and that sort of thing. Please leave me a comment if it's interesting, because I won't cover it in this video. Also, of course, if you find this useful, please like and subscribe to motivate me to make more videos. So step one is you have to go to your environment that has Python 3.10. So I'll do conda activate py310. That's the name of my environment. Okay, so now I have to just do this simple command: conda install -c conda forge TA-Lib, and it should work. That's as easy as pie. When you don't use Anaconda, it's a pain in the ass. It takes forever and it never works. Now let's get started. So first, let's assume we have a data set with all the symbols, let's say the 1,000 symbols, and we have the date, the adjusted close, high, low, open, volume, whatever. And let's say that we will, let's say that, sorry, I lost my train of thought. Okay, so, oh yeah, sorry. This data set is available in my other video on how to get the S&P 500, Russell 1000, and NASDAQ 100 symbols. So you can refer to that video to get this data set. But anyways, the data frame looks like this. We use index column symbol date to get it symbol date. I sorted the index just in case, because you really need the indexes sorted for these types of libraries. So now let me go over the basic usage. So you have this TA-Lib. I imported TA-Lib here. So you have TA-Lib, and then you have your indicator name. So you have all these indicators. Let's use the most famous ones, like Bollinger Band. So if you can do Shift Tab to get this doc string. And so as you see, the parameters are time period, number standard deviations up, down, and moving average type. Okay, so why don't we do something like this? We will put our data frame. First of all, we'll make a data frame just with one symbol. So we'll do data.loc Tesla, just Tesla, because this is just the basic usage. So data frame, we want the closing price, and then we want, let's do time period, let's do 20 day, and we'll do 2 standard deviations for the up, 2 for the down, and 1 is exponential weighted moving average. And what does this return? This returns the upper band, middle band, and lower band. So we're going to save this to variable. df upper, df middle, df lower. Now let's double check that that is what it returns. Oops, sorry. So how do I check that? I do shift tab. Shift tab gives me the doc string. So upper, middle, and lower. Okay. So we'll call this, let's call it BB upper. So it'll be Bollinger Band upper, Bollinger Band middle, and Bollinger Band lower. And let's show how it looks. It's DF, and you see Bollinger Band upper, middle, lower. The first 20 are nans because there's not enough value. Okay, so this is Bollinger Band. So now let's do another famous one, RSI. So RSI, you do TA-Lib, the RSI. Again, we'll look, and it only needs a time period. So we do df.close, and let's do 14 period because that's what seems to be used a lot. And now let's see it added the RSI. And now let's do another famous one, which is the MACD. So let's do TA-Lib.MACD. Now let's see what we need. We need, of course, we always need the DF part, and we need fast period, slow period, and signal period. So usually the fast period is 12, slow is 26, and signal period, I think people generally use 9. So basically what happens is the MACD is the difference between the 12 period moving average, exponential moving average, the 26 period, and the 9 period. As 12 period and 26 period, and then of that you take a 9 period moving average. And what does this thing return? This thing returns, it will return the MACD, the MACD signal, and the MACD histogram. So I'll write MACD, df MACD, the signal, df MACD hist. So it returns those things, and now let me show you how it looks. So now you see you have MACD, MACD signal, and MACD histogram. What is the MACD signal? The MACD signal is the 9 period moving average of the MACD, and the MACD is the difference between the 12 period and the 26 period moving average. And what is the MACD histogram? The MACD histogram is the difference between the MACD and the signal line. So if you subtract the MACD and the signal line, you get this thing. So you see 2.5 minus that is negative. Okay, so anyways, so this is how it looks. So now what if we want to compute it for multiple symbols at once? So this was just for Tesla, but what if we want for multiple symbols at once? Well, we can wrap this thing in a function. We can do like def compute indicators, df, and then we have the indicators here, and then we'll return df, and then we have something like, and you know what, let's actually, I mean, maybe it's better practice to do df equals df.copy, because you don't want to be writing on things and stuff, but it doesn't matter too much right now for our purposes, but now we'd have something like data. That's the whole data. We have to group by level equals symbol, and then apply compute indicators. This is not the full solution. You'll see why in a second. Level, sorry. Level because symbol is part of the index. Why is this not the complete solution? Because it adds the index here, adds extra index. That's just how it works. Whenever you do a group by, it adds the extra index. But we can easily get rid of that index. But see, other than that, everything seems to work. As you see, like just because of the way it's ordered, only at the beginning you see the missing values, but all these symbols should have missing values. So like, let's just say I do sort index level equals 1. level equals 1, ascending equals ascending. I'll do something like this just to show you guys that each symbol has a missing value. I'll do sort index. Sorry. First of all, let's just drop the annoying double index. We can do drop level 0. Okay, so that drops level 0. Let me call it data. But just to show you guys for a second that you have missing values for all the symbols at the beginning, we'll do data dot sort index level equals we'll sort by symbol and date, and then we'll do ascending equals true false true. So meaning that the symbols we're going to do in reverse order, but the dates in normal order. So as you see, when we flopped it and we made Z the first one, we still have missing values at the beginning because there's not enough to compute them. Just wanted to show you guys that. Okay, so this is how you can compute many indicators. Just add all your indicators, give them names, use this function. It should work very well. Okay, so now let me show you guys how to plot these indicators. We'll do it for the Tesla example because we're going to do it one plot at a time. So we're going to need use Plotly Go for this one, and I can make other tutorials for Plotly Express if you guys want. Just please write comments on what you're interested in. So we need graph objects as Go. We need from plotly.subplots import make plots. Why do we need that? Because we want multiple plots. Oh, make plots. Okay, oops. Subplots, import make plots. Okay, so now let's show you guys how to do that. So we're going to create a fig equals make subplots rows equals 3 because we want it for the 3 indicators. Calls equals 1. We want a shared x-axis is true. Maybe we'll have some vertical spacing equals 0.02 just for formatting. Maybe we'll do 0.01. And then we want titles for the subplots. So we have subplot titles. We can have stock price plus Bollinger Band. We can, let me write the full thing, plus Bollinger Bands. And Bollinger Bands. The second one will have relative strength index, RSI. And the third one will have moving average, convergence, divergence, MACD. So these are the titles, right? Sorry, it's a bit hard to see. These are the subplot titles. Okay, so now we're going to keep adding traces. So we're going to do like fig that add trace. This is for the first plot. The first plot we have row equals 1, column equals 1. So for add trace, we're going to do something like go.scatter x equals df.index because the index column is the date. X equals df.index. Y equals df.close because we want the actual plot of the stock itself. And we'll call this name, we'll say closing price. Guys, let's see. Okay, see, as you see, it has just one plot so far. Oh, see, maybe I need actually vertical spacing 0.2 because they're really right on top of each other. So now, I don't know. Hard to tell. Okay, so now let's add the traces for still with row equals. Oh, sorry, I didn't add row equals 1. Call equals 1. It means it's the first one. So row equals 2, call equals 1 would be the second one. Row equals 3, call equals 1 would be the third one. So You have the RSI. Sorry, let me start everything with scratch. You have the RSI. Maybe I need vertical spacing 0.3, if we want 0.4 maybe. So whatever. So now let's add the other Bollinger Band thing. So we'll do add trace. Let's add the upper band and then the lower band. So we do add trace go.scatter x equals df.index. You know what? Let me just make my life easier and copy this. I'm gonna need it a few more times because I'm gonna have the index always, but now I want the upper band, so I'll call it BB upper. That's what I called it. And here I'm gonna have the middle band. I'll call it BB middle. And then here I'm gonna have the BB lower. And then I'm gonna call this, I'll call it like upper band. I'll call this middle band. Call this lower band. Okay. This should work and it should take care of the colors automatically. Yeah, see, you do have the Bollinger Band and it's the first graph. So now let's add the second graph. The difference here is going to have row equals 2 and column equals 1. The second one was the RSI. So we wanted like RSI, SI, and we'll call it, let's call it RSI. And let's see if this works. See, you get the RSI here. Okay, great. The RSI was easy. It was only one thing. So now the third thing we would want, the MACD to add. So again, we want something like MACD are going to want a few things. So let me just copy this. It needs to have row equals 3, row equals 3. So for MACD, what did we calculate? We calculated the MACD, the signal, and the histogram. Okay, so we're going to do oh, sorry, you know what? Another thing, I think, oh, sorry, mode is lines by default. But sometimes you can specify, like here, you can specify like mode equals lines. Because there's other modes like dash, where it's like dashed. But let's make mode equals lines here just to be more precise. Again, I think it's by default, so it doesn't matter. But okay, so for the MACD, we'll have the first thing we'll have is the MACD, and I'll call it the MACD, and then I'll have MACD. What did I call it? I called it MACD signal. So I'll call it MACD signal. And then I have the last one, MACD hist, MACD histogram. See how this looks? Someone's calling me. Just a second. Sorry. So actually the MACD histogram is generally not really shown as a scatter. It's usually shown as like a bar. So I can do fig.add bar, and then fig.add bar I can do x equals df.index, y equals MACD hist, name MACD histogram. Maybe I'll do, you can also have a marker like dark blue, okay, and you can plot the thing like this. Why is this not working? What's wrong with this? What did I mess up on here? Marker color, sorry. Color. Here. now you have, oh, it's really ugly. Oh, because it's having the thing from the past one. So you see like this, you have now the three symbols. You have the MACD histogram here. You can always make this better. But anyways, okay, this gives you the actual plot. So you can optimize this, and if it's interesting to you guys, I can make videos on Plotly more in depth. But now let me show you guys a few more things. Let's create the fun Ipywidget I promised. So we want to first create a drop-down where you can select the symbol. So how are we going to do that? There is, first of all, we do from import Ipywidgets dot widgets as widgets, and then do widgets dot dropdown. Widgets dot dropdown. Widgets dot dropdown. Down, and then you give it a option. So you have like options equals. Let's do the unique symbols. So because I have the symbols in the index, I do index.get level values symbol, and I'll do dot unique, and then I'll do dot to list. So I have this drop down with the symbol. I'll make a description equals, we'll call it select symbol. I don't know. Might cut this off. Let's just do the symbol for now. So symbol. So now you have a widget that you can select the symbols from. So now we want is whenever the user selects a symbol, we want to display the plot above. So how are we going to do that? First, let's put the plot above in a. Hey, sorry, I'm making a video. 2 minutes. 2 minutes. So now let's make this as a function. We'll call it like def plot df, and then we'll do fig.show. Okay, so we'll make this as a function. So now user selects something, right? And we have to be able to like handle this selection, right? So how are we going to handle the selection? So we need a callback function. So the callback function we're going to have is going to be something like on symbol, on symbol selected, right? Change. So let's define a global data frame, and symbol is going to be change new. What is change new? Let me just show you guys just for a second. I'm going to show you guys how it looks like. So I'm going to just show you guys a stupid thing where I print everything. Do print change. I'll do print change first, just to give you guys intuition. But first, let me show you how to. You can attach the callback by using this observe method. You can do like symbol. I have to call this symbol dropdown. Symbol dropdown, and then I do symbol dropdown dot observe on symbol selected, and then names equal value. What does the names equals value thing do again? I don't remember exactly what the names equals value thing does. I have to figure that out. But like now, if you do display, I don't have display, so I need from. Sorry, I'm in a rush also because someone came. By widgets from Python dot display import display, and we're going to need a clear output later. Okay, so let me now display symbol dropdown. So now you have the symbol dropdown. So every time the symbol drop down happens, I printed the change. So if you see the change new is the new symbol. It's funny because it actually chose my name by accident, but ACI. See, new is, new is, oh, because we're not clearing it, it's writing everything all the time. So let me do something like clear output to clear it every time. Oh, sorry. So now, as you see, I do ABDE. It has new ABDE. Oh, but it deleted the dropdown itself. So I'm gonna need, once I clear it, I'm gonna need to put the display dropdown here, because once it clears the output, it doesn't re-put this. So now I select AA. I get new equals AA, old is A. And then it still keeps it because we have the display in here. So now I select ADT, it has the new ADT. So as you see, what we really need, the symbol is really change new. So we need change new. And okay, so once we have change new, that's the symbol, right? So we can use the data frame, we can do df.log symbol. That's the data frame. df equals data.log symbol, right? And then we can plot the df by just doing plot. We'll call our plot df function, and let's see if this works. ADI, look, oh, it deleted it. Oh, because the clear output, we didn't put the display symbol drop down after, so we need the display symbol drop down. And as you see, you have this symbol, and you have these outputs. Sorry this video is a bit rushed. If you like, please subscribe and tell me what other topics you're interested in. Thanks a lot.